Great. I think we are all here. We have a large session today with the 5 panelists and myself and Ron McCandless co-hosting the webinar itself. So thank you for joining us this afternoon. We'll have about 1 hour presentations and about 10-15 minutes of panel discussion. And then after that, about 10 minutes of Q&A from the public. So I will be asking people to post their Q&A. At the very bottom, there's a Q&A box, so you can actually post your Q&A over there. So let me start with my introductions. So I'm going to ask the panelists to switch off their microphone and their video, and I will share my screen with my presentation about the Acces.space Alliance. I presume everybody can hear me, and I'm going to then start the webinar. All right, thank you everybody for joining us this afternoon. We will be discussing about moon landers, especially commercial landers, basically going to the moon very soon. This will be the first of a series of webinars on the moon. We'll have a few others on communications, on the business side, on the finance, on the regulatory side as well in the coming months. Approximately 1 webinar of this kind a month, which we'll discuss through the Committee for Lunar Development. Okay, we started off these webinars about 10 months ago in April 2020 to cope with the lockdown due to the COVID pandemic around the world. Also to help companies to continue to showcase their company, their ideas, their projects with everybody else around the world. And we have got some very good attendance from pretty much all over the world at these webinars. Today's agenda, as I said, will be discussing first on how we approach and spearhead companies, commercial companies into the moon. We'll have 5 panelists, about 10 minutes each presentation. We'll have a short discussion at the end and a Q&A sessions. For those that would like to use this presentation, the slides, as well as the recording afterwards, for your own work, please be minded that this is proprietary information and copyrighted. If you would like to use it, just mention the authors of the slides as well as the webinar, Acces.space Alliance webinar, in any way or shape you're going to mention this material. I'll talk about a little bit about this Acces.space Alliance for a few minutes. We are the directors on the slides. Betty, myself, and Christians are all volunteers. It's a non-for-profit organization which was created 2 years ago, in March 2019. We all work and have our different expertise, which we provide to the Alliance. And as we grow, basically, we provide those expertise to the Alliance itself. So we are a non-for-profit organization for the small satellite sector, although we have companies that have come from larger organizations, basically, as well. The mission, in any case, is to create an environment that allows space entrepreneurship to thrive and prosper. We have also started our formal membership in January this year, with basically starting from this month in February, we have now 36 companies and universities will have joined. We expect more to join us, and this is coming from a 2-year experience in 2019 and 2020 with about 90 companies following us in our sort of activities. Now it's been formalized, and if you're interested into joining the Alliance, let me know, email me, or otherwise go on the Acces.space website, click on membership and also on join if you'd like to also find out a bit more about joining the Alliance. We have already put together several committees. We have one on free space optical communications, one on regulatory and space policy. The one that we are now discussing today is the Lunar Development Committee, for which now we are creating these webinars once a month. A finance committee has been created this month. We had our first meeting last week, and there will be others coming soon. In fact, there will be new activities with the formalization of the Alliance. So we will be organizing also roundtable discussions, talks, lectures, conferences. We had our first conference, in fact, in 2019, a successful one, which was hosted by the European Space Agency in the UK. We will be putting together an advice bureau for members that require some advice in particular areas of their requirements. And we will be also attending international space meetings and conferences as well this year. And we are organizing a conference in April. If you would like to see past recordings, you'll find them at this link. You don't need to actually write it down. I will forward you the presentation afterwards to your email you registered to this webinar. So today's panel made of these 5 panelists. We have Stephanie Gowell from Masten Space Systems, Dan Hendrickson from Astrobotics, Will Coogan from Firefly Aerospace, Trent Martin from Intuitive Machines, and Julien Alexander Lamamy from ispace Europe. Hosting the meeting today will be myself as a general host, basically, and then Ron will take care of the panelists and their presentations. Ron is from Commstar Space Communications. We have 203 registered people and now about 92 people who are attending live. The other people will receive the presentations and also the recording respectively. So thank you for attending live right now. As you can see, the registration always has a prevalent number of UK participants. This time also many from the United States, but we also have India, Germany, quite a high numbers, and Europe. We could see the distribution regionally, about 60%, 58% from Europe, Americas, and the rest of the world. You can see from the pie chart on the right side. If you want to see a breakup of the companies by a number of companies versus size or number of registered people by company size, you'll see from the slide, you see there's a lot of participants from very small companies, quite about a high number, about 75, and then about 10, 15 from the rest of the size of companies, basically. We'll start the webinar now, and I'm going to call upon Ron to take over. I'm going to now stop sharing my video. And then Ron, it's up to you now. Thank you for participating, Ron. Thank you. Bye.
Thank you. Thank you very much, Tony. This is a pretty exciting time, as we all know. We're about to head back to the moon in full force, led by governments and private companies. And what's really exciting about the group we have today of these 5 companies and others is that this is a sort of a culmination of a long process. Many of these companies were part of or started in the Google Lunar X Prize competition that ran from 2007 to 2018. And many of them developed a lot of their technologies over that time period. And now of the 5 companies represented today, 4 are from the US. These 4 are part of the NASA CLPS, Commercial Lunar Payload Services Program. And these 4 are the 4 winners of the 6 task orders generated so far by NASA. So congratulations to all those companies that are part of today's webinar. So what we want to do today is we want to give each company 8-9 minutes to tell us about their plans for their lunar lander plans for exploration, what they intend to do, some of the challenges they face. And what we'll do is after each company presents, we will transition to the next company and so on and so forth to hit all 5 within this hour. But then we'll have a panel session, like Tony said at the end, where we'll ask some free-form questions that I think will be pretty interesting and give us some indication of where these companies want to go, from here, from beyond their initial missions even. So I'd like to go ahead and get started. And first up is Stephanie Gowell from Masten Space Systems. And Stephanie's a business development engineer. And Masten is one of the companies that's, like I mentioned, is flying on a NASA CLPS sponsored mission. They're flying at the end of 2022, so at the end of next year, an exciting mission to the lunar surface. So I'd like to go ahead and turn over to Stephanie and give her her time.
Thanks, Ron. I'll start to share my screen. Sorry. All right, so as Ron said, I'm Stephanie Gowell. I'm a business development engineer at Masten Space Systems. I'm going to go over kind of the history of Masten, our terrestrial demonstration, and our Masten Mission 1 that launches in 2022. So who am I? I'm a systems engineer with aerospace degrees that kind of learned that I like business development more than I liked being a systems engineer, and transitioned over into business development a few years ago. I've worked at large companies and recently transitioned to startups a couple of years ago. I joined Masten in August, so I'm still fairly new at Masten, and I work remotely for them from Northern Michigan. So about Masten. Our mission is to accelerate the realization and impact of game-changing space architectures for the benefit of humanity. And so you'll notice this isn't lunar specific. Lunar is just kind of where we're focused right now. And as Ron mentioned, we did participate in the NASA Centennial Challenges for the Lunar Lander Challenge in 2009. And we actually won the challenge back then. So Zoe, our vehicle shown here, won the NASA-funded Northrop Grumman Lunar Lander Challenge in 2009, expending the same delta V as a rocket descending to the lunar surface from lunar orbit and demonstrating reusability. So we've been in the game for a long time, building our technologies to be prepared for this 2022 mission and win our CLIPS contract we won a year ago. Here's just another cool photo of that flight. Next, I was going to go over our terrestrial test bed because it really is what feeds our technology for our lunar missions. So the terrestrial test bed is out in Mojave, California. This is where enabling technology allow third-party landing systems to fly our rocket easily. We've demonstrated precision landing technologies for JPL, NASA, Astrobotic, and others. Something that I thought was particularly interesting as of late is that the terrain relative navigation with a sensor called the Lander Vision System and the guidance for fuel optimal large diverts algorithm, and we tested these in a technically challenging multi-year series of closed loop flights. These payloads flying on Masten rockets successfully simulated entry, descent, and landing on Mars at our Mojave test bed. So these are part of the Mars 2020 mission, and I thought that was a fun little fact for this week. Flight campaigns, so we provide access to relevant test environments to multiple technologies. We had two major campaigns on our Zodiac vehicle last fall, and these campaigns are designed for payloads. Sorry, my computer's lagging sometimes. All right, and then we do iterative testing. So a thing that I've learned at Masten in my short time here is we're all about iterative testing. And so we start with a tether flight and move to open loop flights and then closed loop flights. And then, you know, we tweak and we refly within 24 hours if the payload and weather are permitting. So with this mindset, we have flown over 600 reusable rocket operations, and this has helped us develop the skill sets and technology we need to be a successful lunar lander company. Here's another cool photo of one of our flights out in Mojave. All right, and now to focus more on our actual mission, Masten Mission 1 and our lunar lander. Xl1 is Masten's first lunar lander. Masten provides end-to-end delivery services to transport customer payloads from Earth to the moon. Using this landing technology developed and demonstrated over a decade of our flight testing, we provide lunar access for customers pursuing scientific discovery, technology, demonstration, and commercialization of cislunar space. Today, we are manifesting more lunar missions to all near-side lunar landing locations, and we'll deliver these payloads using Xl1. For these lunar missions, the primary customer will specify the delivery date and site within the mission constraints listed in our guide, our payload user guide. So this is a cool rendering of what the Xl1 will look like. And on my next chart, I'll go into Masten Mission 1, which is the mission Ron was referring to in December of 2022. Masten will execute this mission to land on and explore the lunar South Pole. This is part of the CLIPS program. We were awarded this about a year ago. Using the Xl1 lander, Masten will safely deliver payloads to the lunar surface to perform a variety of science experiments, technology demonstrations, and other activities that advance the understanding of the moon and its polar regions. This early mission is a critical step to NASA's Moon to Mars roadmap, by serving as a precursor for future human missions and by continuing to demonstrate the viability of the commercial industry's role in lunar exploration. To date, Masten has manifested 9 NASA-sponsored science and technology payloads to fly on Masten Mission 1. These are through the Commercial Lunar Payload Services, CLPS, program with NASA. These payloads consume a fraction of our total delivery capability. Masten welcomes additional partners to join this historic mission and together to continue building a sustainable and vibrant economy around the moon. So reach out to me if you're looking to go to the moon in 2022 to the South Pole. Our landing site was selected with NASA. They are our primary customer. So as I mentioned earlier, our missions, the primary customer helps or determines the landing site. So NASA recently announced publicly that we will be landing specifically in the Hayworth crater at the lunar South Pole. And then, since I really focused on our current mission, I wanted to put in some info showing we are thinking longer term. So I focused on Xl1 on the left here mostly today. We have 2 other vehicles in our Lunar Lander roadmap. One is XL2 and the other is Zeus. This is a pretty rendering of XL2. This is Masten's second proposed lunar lander that will build off of the capabilities of XL1 to provide larger payloads, increased precision, and higher mission flexibility. The lander is iterated from Zeus, which I'll show you on the next slide, and enables large payload delivery or integration with NASA's Human Landing System, or HLS. It utilizes a dual cryogenic reusable descent element, and existing components and subsystems from our extensive catalog are used to maximize value and flight heritage on XL2. Zeus is a concept that Masten has spent significant time developing with the capability to demonstrate heavy lift cargo delivery to the moon. This concept is based off landing an upper stage fuel tank horizontally, providing easy access to the surface for a large amount of payload. Zeus is not actively being pursued, but the core concepts have been developed and lie in wait for us as Masten customers want to expand their lunar cargo delivery capability. And come fly with us on our terrestrial test bed or go to the moon with us. If you have any questions or want to reach out about future missions, please contact me. My email and info is on the screen right now. Thank you all.
Thank you, Stephanie. That was a great presentation. Just have a quick question. You do have that mission 1 coming up. If people are thinking about a possible payload, what's the timeline that they have to sort of get engaged with you by to be able to make that manifest?
Yeah, so like I had mentioned in the charts, we like to test early and often. And so the sooner payloads can get to us right now, the better, because we're trying to increase the testing early on so that we have less risk technically. So there is maybe more of a schedule push right now, but we're trying to do the iterative testing. So the sooner people can reach out to me, the better, and we can start having discussions to figure out the right timeline.
Great. Thank you very much, Stephanie. Appreciate it very much. Like I said, we got to keep on schedule, as Tony said, I should say. So we're going to move on to Dan Hendrickson from Astrobotic. As most people probably know, Astrobotic won the first CLPS contract some time ago and have since got another one. And Dan's going to talk about those using a couple of their landers, the Griffin and Peregrine, and also about some other exciting stuff coming up. Dan, ball's in your court.
Great. Good morning, everyone. Thanks very much, Ron, for that introduction. My name is Dan Hendrickson. I'm with Astrobotic. We're a lunar logistics company based in Pittsburgh, Pennsylvania. We were founded back in 2007 to make the moon accessible to the world. And to that end, we put a heavy emphasis on our end-to-end lunar delivery services that are powered by the product lines that you see here on the screen. On the left are our lander product lines that you can see our Peregrine lunar lander here at the top left. This is our smaller vehicle. It can carry up to 100 kilograms, depending on the destination. Our Griffin lunar lander is a larger vehicle carrying 500 kilograms of capacity to the surface. And then as an extension of our end-to-end services and an extension of the lander services in particular, we also offer mobility on the surface for payloads. So it's possible to have payloads at a small scale, 2 to 6 kilograms, depending on form factor and need. On board our cube rovers, which you can see on the top right corner. These are rovers that could be on Peregrine or Griffin or really any lander mission because they're meant to be small and low form factor and create the ability for really anyone around the world to have the capability to build a payload and get access to the surface with mobility. And then in the bottom right, we have our Polaris lunar rover, which is our much larger lunar rover that matches well with a Griffin or a larger lander, providing a surface capacity up to 90 kilograms. And it's much more of a workhorse vehicle, if you will. So with these vehicles, we've got a pretty robust manifest coming up, as Ron had mentioned. So for our first mission, we'll be flying our Peregrine lunar lander this year in Q4. So we're very excited to be kicking off the first US soft landed lunar lander mission since Apollo 17. It's a very big moment for the US and for the world, because we're also carrying 6 other countries in the form of 16 other customers on board the mission. So NASA CLPS, as mentioned, is one of our customers on board this vehicle, but we've also got a number of other customers that I'll highlight here in a moment. So you can see here, this is our manifest that we have on board. We have NASA CLPS on board, as you can see on the screen, but then a whole variety of companies, governments, universities, and nonprofits from around the world that are also signed on. Because this is a commercial service, is a commercial mission. NASA is one of 16 that are on board. So some of the names that you see on this manifest you might recognize. DHL, the world's largest shipping provider, is a sponsor and providing some marketing assets on board the vehicle that we're carrying on board this manifest. We also have payloads from companies. So for example, SpaceBit that you see here on the screen, they're doing a technology demonstration on the lunar surface. So this is a straight business-to-business payload deal involving no space agency or government. Then we've also got, in the case of AEM, the Mexican Space Agency, another space agency outside of NASA that is on board and flying. So they'll actually be doing a pretty exciting rover demonstration that involves sort of disaggregating assets and determining whether you can do disaggregation on the lunar surface with multiple small rovers at once. And see if you can do what a large rover would be able to normally accomplish. So a whole variety of different organizations and a whole variety of new visions really that are being brought to the lunar surface with this first mission. Then in 2022, we're carrying out our Moon Ranger mission. So this is a rover that will actually be flying on Masten's flight that you just saw a briefing on. That is a CLPS payload, so it's flying through the NASA CLPS program. But we consider it a mission unto itself because it's going to be doing some pretty exciting activities on the surface. So this is a standalone rover that'll be delivered by that lander, as mentioned, but we'll be carrying out a variety of autonomy technique tests on the surface. Most rovers in the past have been direct command and control. This will actually test autonomy really for the first time when it comes to rovers on the lunar surface. And then it'll also be carrying a neutron spec and doing an early demonstration and experiment looking for water ice on the surface. So pretty exciting to be kicking off lunar resource investigations with this mission in 2022 that'll be going to the South Pole. Then in 2023, we'll be delivering the NASA Viper rover on board our Griffin lander. This is a mission that'll be going to the South Pole of the Moon. It will be carrying out the first large-scale ground truth measurements of lunar water ice. So this is a really exciting mission for anyone that cares about the moon and really about space exploration in general, because the findings from this mission could have great implications for the economics of going beyond Earth orbit, namely because you could potentially utilize that water ice for the purposes of life support and rocket propellant. So it's a very exciting mission to kind of kick off a new era on the moon as well as in space in general. And so we were very humbled to be selected by NASA for this delivery. Obviously, it's a nationally important mission and one that many folks around the world will care about quite a bit. So we're very excited to be selected and making progress on that mission right now. So to that end, we're making a lot of great progress on all of these programs. In particular, in the top left corner, you can see our Cube Rover is being tested here. So this is a test bed that has tested over 11 different types of wheels at NASA Kennedy Space Center. This vehicle has gone through 150 tests, so it's being hardened and readied for flight. So this is really, again, a platform that you can see can be utilized for payloads around the world. Payload actually goes under that platform, so it's really meant to be very flexible for a variety of different form factors and mass types. On the Peregrine program, we're making great progress toward the mission this year. A lot of key testing has occurred on payloads in particular. There's an image there of one of the water detection instruments that'll actually fly on Peregrine mission 1 and then will be utilized later on the Viper mission. So this kind of gives you a sense of what's changing on the moon, in the sense that you could do a test with one mission and then just a few years later follow it up with a full investigation if that instrument works well. And so it's a pretty exciting new dynamic that we're seeing for carrying out activities in space in general. And then in the top right, you can see our structural test model's been put through its paces, gone through vibroacoustic testing. It passed with flying colors, so very exciting to now be progressing toward integration with that test well behind us. On the bottom left, you can see a few images from our Griffin program. We've done some hot fire tests with our ACS engine partner, Agile. So they've already done hot fire tests with the ACS engine that we selected for Griffin. And then also on the right of that image, you can see the axial engine being tested by our partner Frontier. So a lot of great propulsion testing. Obviously, that's a pretty key and important development necessary for progressing to flight. And then in the bottom right corner, just an image from our Lunar Headquarters that was opened here in Pittsburgh, 47,000 square foot facility that just opened in late summer. It's got labs, a mission control room, open office, as well as a number of key facilities for integration, spacecraft high bay. So we're very excited to be open for business because it can really host a number of spacecraft developments simultaneously. So we can do, for example, 4 lander mission integrations at once, as well as rover integration. So we're really set up for pursuing the moon long term. You can really think of us as the moon company. So there's a couple ways that you can join the mission. I'll just highlight very quickly that we have a number of resources available right now at the ready. We've got our payload users guide available. We also provide an interface design document, and we also have a number of payload managers that are ready to work side by side, shoulder to shoulder, to ensure that your integration of your payload be successful. So we've got a pretty strong support system. So please reach out and let's have a conversation about how best we can support your payloads. And then lastly, I'll just note that we're hiring. We've got 119 folks here at the company, and we're steadily growing. We'll have many more here by mid-year. We've got a number of positions open, so please do check out the website. We're really excited to bring on world-class talent to be making history together. It's an exciting time to be pursuing the moon here at Astrobotic. Thank you very much.
Thank you very much, Dan. That was a great presentation, and due to time considerations, I will not be asking you a question, so you got off easy. So we're going to go on to our third company. That'll be Firefly, and William Coogan, Lunar Lander Chief Engineer, will be talking about what their plans are for the landing on the lunar surface, and they recently won a NASA Eclipse contract. So congratulations to them, and we'll let William talk about it.
Thanks for the introduction. Yeah, so I'm Will Coogan. I am the chief engineer for our Blue Ghost lunar lander. And as Ron just mentioned, we actually won our contract from NASA earlier this month. So it's a very, very recent award. Okay, just a little bit about Firefly. We are a Texas company. We have presently over 300 people on staff. And we do pretty much everything you can imagine related to space, including our Alpha launch vehicle, which is set for its inaugural launch, I think, next month, but in the coming weeks. And now, of course, this lunar lander. We do pretty much everything in-house. We do our own welding. There you can see that's actually the release mechanism for our Alpha launch vehicle that's now out at Vandenberg Air Force Base. You can see in the top right, our launch vehicle integration facility is a big warehouse at our test and production facility out in Texas. In the bottom right, you can see yet another large warehouse at that same location. We've got a 200-acre test and production site. And that's entirely dedicated to machining. So we've got all 5-axis CNC mills, CNC lathes, pretty much anything you might need to make something out of metal. And then we have expertise also in composites. We lay up our entire composite rocket ourselves, and that includes the cylindrical structure, the domes on the tanks. We have linerless composite cryo tanks for our launch vehicle. And there in the bottom middle, you can actually see some of the tools we use to lay up those composites. Here in the top left, you can see an aerial photograph of our facilities. They actually extend quite a bit off to the left and toward the viewer compared to what's seen here. I'll point out just some of the key features. Here you can see 2 of the large warehouses I mentioned before. We actually have a 3rd one going in now for automated fiber placement. Automated fiber placement is sort of like 3D printing, but for composites. This is already used in aerospace for airplanes. Essentially, you have a machine weave your composite structure. So very little touch time from technicians, and it gives you a very consistent result. We have a vertical rocket test stand at this facility, so we can test our 1st stage or our 2nd stage for full mission duration. We've already completed acceptance testing for both stages for our 1st launch. We also have another test stand that we can use to, squish and twist the structures, make sure they're going to survive launch loads. And then another horizontal test stand where we can test up to 4 engines operating at once. And then the top, you can see our approach for both launch and for landers, which is just to test like you fly. We've here got 2 different test facilities back to back where we are testing our rocket as if it is launching. We have a similar facility set up for our lander as well. And we're actually able to operate both of these at the same time. So we can be firing a rocket on the horizontal stand and on the vertical stand in rapid succession. And there's one more picture of some of the stuff we've worked on. We wind our own composite overwrap pressure vessels. We've got a philosophy: make it fast, break it fast. So we make them, we pop them. You can see just kind of debris going everywhere there. We make all of our own tanks for cryo stuff, and of course have to test the expansion of those things. Every rocket has to have a self-destruct. So we've tested that. We put it next to a composite overwrap pressure vessel in a shipping container and exploded that. So you can see what's left of it there. And then of course hot fires for all of our rockets and stages. We've got hardware in the loop test facilities that are used for both programs. When we do an integrated stage test, of course, we have all of the avionics integrated, so we practice shaking those. And of course, we've got to repeatedly test to make sure that the fairing opens and deploys the payload. So for most of our history, we've been primarily focused on the Alpha launch vehicle. With this award, though, there's a lot more focus shifting to our Blue Ghost lunar lander. We've had sort of a Tiger team working on this for the last 3 years or so. And now with this award, we're shifting a lot of people over from the launch side of things, and also leaning on some of our key teammates who we propose to work on this mission with. So at Firefly, obviously, you just saw we have a lot of expertise in propulsion and structures. I don't think I mentioned, we make all of our own engines for the launch vehicle. So we build it, we test it, and very soon we're going to fly it. We've also partnered with Deep Space Systems, which is actually another CLIPS awardee. They have expertise in space cameras. They have 15 megapixel cameras, which just create beautiful imagery, which I think we've all seen is extremely important, especially on the very recent Perseverance landing. And they also have expertise in vision navigation over the lunar surface. We are also working with Advanced Solutions, or ASI. They have a lot of expertise in GNC and also in flight software. They're actually the creators of Max Flight software and the Solus package. So you can do like a digital version of a hardware in the loop test, but you can test faster than real time because it's all digital. So you can test thousands of times in a matter of hours and actually generate a Monte Carlo and dispersions to figure out how your spacecraft is going to be performing on orbit. So it lets you close on design very rapidly, very powerful software. Both DSS and ASI, as well as from Firefly, have all worked, EDL, entry, descent, and landing missions for Mars rovers. And then finally, we are partnered with SpaceWorks, who have a lot of expertise in systems engineering. So let's look specifically at our Blue Ghost Mission 1. This, again, was very recently awarded. The contract was for $93.3 million to fly 10 different NASA-sponsored payloads and to operate them for a full lunar day on the surface of the moon. This is set to land in the middle of 2023 at Mare Crisium, which is on the near side at a mid-latitude. I don't list all the sponsored payloads here. There's never room to list all of them. I don't want to pick favorites, so I try and rotate through them, but just to call it a few of the interesting ones. We're measuring the distance to the moon now to less than 0.1 millimeters, which over a distance of 400,000 kilometers is very impressive. We're going to be taking observations of the Earth's magnetopause. You can see this payload here on the top deck, pointed approximately at the Earth's magnetopause. And then another really cool one, there's GPS being tested at the moon. You may know the GPS network, it consists of satellites mostly in medium Earth orbit. So when you're this far away, to be looking back at those satellites and trying to pinpoint your position, it's very challenging to do, but also very useful as a technology for landing on the surface of the moon. We're trying to, all these companies are trying to navigate based on looking down at craters that largely look the same and on, ranging from ground stations on Earth. And so, having something like GPS would really, it would really be a big step in enabling precision landing on the moon. NASA is supposed to be just one of many commercial customers, and what we have remaining to sell is 50 kilograms of payload capacity, as well as 10 megabits per second of downlink capability, and that's after half-rate encoding. So that's actually enough for high-definition video in real time. So lots of possibilities available there to the commercial community. In terms of progress so far, again, we've had this award for about 3 weeks, so we've tried to hit the ground running here. We did work quite a bit at risk in advance of this award, which is, I think, part of what gave NASA some confidence in our schedule. We've got a lot of our key long leads already ordered. Some of them are actually already received, including our propellant tank domes, which are our longest lead item, actually. We actually went through a preliminary design review back in June of last year. We didn't know exactly what this Eclipse 19D mission would look like, but we did know which payloads might be on it. So we were able to kind of make an educated guess as to what the requirements might be, and then pursue a PDR in advance. So we are, of course, now going to have to do a Delta PDR now that we actually know what the payloads are. We've had a chance to speak with the payloads and capture some of their requirements. And that's really our focus right now, is just working with all the payloads, make sure we capture their requirements, and make sure we give them and NASA the best possible value for their investment. Where we're going in the future, we don't really have a line of different landers we're working right now, but there are some key capabilities that we are working toward. One is far side missions. We know that NASA is interested in going to the lunar far side as soon as 2024, and that poses some significant communications challenges. Surface mobility, just rovers getting around on the surface. There's, I think, over a dozen different companies working on rovers, so there's a lot of interest in that. Lunar nighttime survival, in terms of what NASA and our commercial customers are paying for, it's more than mass, it's data, right? So if you can extend the lifetime of your lander by double or triple or even more, that's a significant return on investment. And then, of course, sample return, as we've seen recently demonstrated for the first time in quite a while by the Chinese lunar program. And really our goal is just to establish the infrastructure that's going to be needed for the presently nascent and unforeseen cislunar markets. I think every company on this panel probably expects this market's going to really be taking off in the next few years. And we're really looking forward to demonstrating successes on this program from both Astrobotic and IM in the coming year. And that's it for my slides. So I'll turn it back over to you, Ron.
Hey, thank you, Will. That was great. And again, we don't have time for questions, but everybody Google Blue Ghost and Firefly, and you'll get a couple of interesting results coming from that. Next will be Trent Martin from Intuitive Machines. He's a VP of Aerospace Services there. And Trent's going to be talking about what they're doing, and they've won 2 CLPS contract awards as well, one going this year and one going late next year. So it's a pretty exciting time for Intuitive Machines, and I'm going to turn it over to Trent.
Yeah, good afternoon to most of you. Good morning to some of you. Hopefully you can see my screen. Let me share this full screen. Okay, so I'm Trent Martin. I'm the Vice President of Space Services for Intuitive Machines. I'm also the Lunar Payload and Data Services Program Manager, which means I manage all of our lunar missions, of which we currently have 2 that we've won through the CLPS program, and I'll talk a little bit about the manifests as we go through this today. You can see my email and phone number here if you're interested in calling and talking about opportunities on any of our missions. The heritage of our company is that many of us came out of the Johnson Space Center, and in fact, quite a few of our employees worked on the Morpheus project within NASA. The Morpheus project was a terrestrial test bed for a lunar lander. And in this case, we flew over 54 times, and you can see that we believe in a fail-forward approach even back when we were with NASA. This is on the bottom right is an explosion of our first Morpheus vehicle, and 9 months later, we were flying the second Morpheus vehicle. And that included 15 free flights of the vehicle and around 40 tethered flights of the vehicle. With that, we have expertise in propulsion, structures, GNC, flight software, hazard avoidance and detection, and deorbit descent and landing, which is what we call it when you're landing on the moon, because you're not entering atmosphere, so it's not entry, descent, and landing. We have quite a capability that we've been developing at Intuitive Machines. It includes our Nova C lander, which is our lander that can carry 100 kilograms of payload to the surface of the moon. And then we expand that out into other landers, which I'll talk about in just a minute. But as part of that, it's not just building a lander that's required. You have to build the entire infrastructure necessary to provide an entire service. So you have to be able to integrate with a rocket, launch it to the moon, communicate on the way to the moon, communicate once you're on the moon, have an operations control center, and develop any of the hardware necessary to do the job. So you can see here that our team is made up right now of around 120 employees. We're on our way to around 160 by the end of the year. Mainly PhDs and master's degrees in the company. About 85% of our company have advanced degrees. And you can see that we were founded in 2013. We have traditional aerospace accolades when it comes to registrations, AS9100, ISO 9001, those kinds of things, which we use in our markets within NASA and aerospace companies. But we're looking at more than just lunar landings, and I'll talk a little bit about that in some of the upcoming charts. But you can see here up on the right that we have other space products, end-to-end lunar services, space comm engineering services, and space nuclear when it comes to surviving the night. So here's our end-to-end lunar missions. Over the next couple of years, we have 2 missions that we've been awarded. Our IM-1 mission will launch later this year. It's to a mid-latitude, and our IM-2 mission is late next year, and it goes to the lunar South Pole. The landing site for the IM-2 is not exactly determined yet, but somewhere within 6 degrees of the South Pole. But we work with our sister company, X Energy, and we're working on space nuclear so that we can solve the challenge of surviving through the night, whether that be a mid-latitude where the night is 14 days long, or a South Pole where the night may be several months long. And so we believe that to be one of the key things that all of the companies that you see here today are going to require in order to make this a sustainable market in the future. We have other advanced technologies that we've developed for our landers that we are now selling out into other applications, things like the human lander and other applications outside of the cislunar market into GEO or LEO. So you can see that the progression of our Nova C lander here at the beginning, a Nova D lander, which can carry 500 plus kilograms to the surface of the moon, and our Nova M, which is the idea that you could carry large, 3,500 to 5,000 kilogram payloads to the surface to provide infrastructure for larger missions, things like human missions to the moon that would require you to land larger payloads in preparation for creating a base on the moon. And as some have mentioned, there's quite a number of folks out there working on rovers for lunar technology. So we got into the idea of extreme environment surface mobility. So getting into places where rovers can't get. And with that, we won a NASA Tipping Point Award this year to put a demonstration hopper onto the South Pole on that mission in late next year. And then we propose putting hoppers in other locations for scientific purposes. The idea being that similar to what you would do on the ground with a drone, you should be able to do that on the moon as well. The advantage that we have here is that we can use our guidance navigation control systems that we would use for our lander and just add a propulsion system and some avionics to it and some places for payloads, fly that off of the lander and land down into a permanently shadowed region, into a crater, across some scientifically interesting area that you wouldn't want to fly your large lander across, but you're more than willing to fly your 30 to 60 kilogram hopper across. We've completed our what we call Nova Control, which is our mission control center here in Houston, and we've been using it for our simulations that we've been doing for our first mission. We've completed our completely commercial communications network with various contracts with ground dishes all across the planet that allow us to get 24/7 coverage from the lunar surface using multiple dishes. That I showed 4 here, but there's actually many, many more dishes that we pick up across the planet. Some get us pretty high data rates and others much smaller data rates. So it's just a matter of defining the mission and making sure that the data profiles meet the expectations. So here you can see our first mission in 2021, and the manifest includes NASA payloads, but also includes commercial payloads, kind of a good mix of both. And those are purely commercial payloads, customers that came to us looking to fly, and we fly them based on their mass, power, and data. IM2 right now includes a Eclipse payload, which was the Prime 1 drill and M-Solo, which is in preparation of the Viper mission that Astrobotics is flying. We will test out the drill and the M-Solo. Actually, the M-Solo will have flown a couple of times previously, but the drill in particular to prove that it functions at the South Pole as expected, so that when the Viper rover makes it the next year, they are confident that it will function. In addition, though, we added a couple of tipping point payloads to that. One is our hopper that I just talked about. The other one is a Nokia LTE to essentially test 4G LTE on the moon to prove out communications capability at high bandwidths between infrastructure on the moon. And we're currently selling space on that mission. We have around 50 kilograms of available mass to the surface. We could also parlay that into 150 kilograms into low lunar orbit. And we have 1,200 kilograms available to TLI for that same mission. So anyone looking for that, give me a call. We're actively marketing that. So you can see here on the right how we stack our mission. We fly in a Falcon 9. We're a little bit different than most of the other lander companies in that we fly a LOX methane cryogenic lander. And the key advantage to that is that it allows us to get to the moon very, very quickly. In fact, we arrive at the moon within 3 to 5 days of launch, and we only go through the Van Allen belts 1 time. Because we get a TLI from the Falcon 9. As an alternative, we can launch to a GTO orbit and go through the Van Allen belts 3 times, but use our engines to kick us to the moon. Still, we can be there within 5 days or so with that kind of a scenario. And with that, I don't have anything else. If you guys have any questions, I'd be happy to answer them. Thanks.
Great. Thank you, Trent. Exciting times ahead for Intuitive Machines with your 2 missions already planned and those other ones in the pipeline. Wonderful. Yeah, if we have any questions, again, put them in the chat, and we'll have a session at the end of the webinar where Tony will be presenting your questions to the panelists today. Our last, but not least, is Julien Lamamy of ispace. He is located in Luxembourg. As you probably know, ispace has Japan, Europe, and also now the US. And so ispace is growing fast, and Julien's going to talk about their plans for their lunar lander capabilities and what they want to do on the moon. Over to you, Julien.
Thank you, Tony. Thank you, Ron, for the opportunity to introduce ispace today and provide updates on our missions. And I look forward to answering questions later on. So on this slide, you can see a rendering of our lunar lander and rover. This lander will launch also in 2022 next year, along with a bunch of other lunar landers. I would say one of the distinguishing features of ispace is that, for example, this lander here is in the final stages of development by our team in Tokyo. We'll start final assembly, integration and test in Germany at Iron Group's facilities. And then we'll head to Florida next year for the launch with SpaceX. So a truly international mission. And this international feature is also, represented when you look at our staff and geographical locations. We have also, above 100 employees at ispace. But you'll notice we have 25 nationalities. Here in Luxembourg for a while, we actually had more nationalities than employees represented in the office. So we can really pull from talent that's available across the globe, and anybody can work at ispace. You also notice we have 3 offices, so headquarters in Tokyo. I'm here leading the team in Luxembourg, and the US office is getting stronger and stronger, and is recently relocated to Denver, Colorado. Another distinguishing feature of ispace is that we have really strong capital backing. You can see on the bottom right, our Series A, Series B, and all the investors that participated that have also become partners in some cases. So it's very, private commercial approach. And the last thing I think that's distinguishing ispace from other companies in this business is the emphasis on a very strong vision. We believe in expanding human presence in space, and we believe the best way to do this is to go to the moon, expose the value of space resources and the lunar resources available there, water among others, and use that to create a lunar economy that will enable permanent presence off-world in space. This can seem cartoonish, but this concept of Moon Valley 2040, the first iteration of this Moon Valley is already present. It's all those companies I just mentioned, our investors, our partners. These are largely non-space companies really interested in engaging with the moon, who believe in our vision and want to position themselves in which will be a budding economy. In order to realize this vision, we see 3 main challenges. First, transportation, providing private and affordable transportation to the moon. Second, exposing the value of the resources available on the moon. And third, building the industrial ecosystem that will generate this Moon Valley 2040. In order to tackle this first challenge of transportation, we also have 2 lunar missions. We've confirmed launch contracts on Falcon 9s with SpaceX. First one, as I said, will be next year in 2022. And then we have a follow-up one in 2023. 2021, the mission 1 is booked at this time, but we're also looking for people interested in following us on the second mission in 23, most likely to the South Pole. You can see that, so we depend on SpaceX to also put us, in Earth orbit, and then from there we enter orbit around the moon, do the descent and landing. We also have rover capabilities to provide surface mobility, and we also have a very strong development in data analytics and interpretation of lunar environment data, resources, and so on. Starting in M3, so our third mission after the 2023 one, we will deploy the next generation lander currently being developed in ispace US in Denver. To tackle, the second and third challenges I mentioned earlier, in addition to our transportation service, which includes the Lunar Lander and the Rover, we also are developing, as I said, Lunar Data Analytics, a data service. Upstream, I would say, is meaning we have tools that can calculate automatically, what are the best landing sites for a given mission, given on science objectives, given the customer needs, can calculate your illumination conditions, your Earth visibility conditions, can help you plan your rover traversals if you want to do rover mobility. So basically a set of tools available online that can help anyone interested in doing lunar operations to start planning their missions today. And on the back end, we are developing our data processing pipelines to process not only our data, but also third-party data, and start building this concept of a virtual twin of the moon, going all the way to interpretation of data. So looking at the data products and performing the economic assessment of the resources, business feasibility of opening resource extraction, and the whole resource business around that. So that's in tackling the second challenge of exposing the value of space resources on the moon. The third challenge regarding developing the lunar economy and ecosystem, we have a strong partnership program. You can see here many of the logos that of the companies that have joined that program already. You can recognize Suzuki, Japan Airlines, for example, among many others. As I said, a lot of these are non-space company. For example, MSNAD is an insurance company. And it's the first insurance company really testing the lunar waters, if I can say, trying to get first positioning in what will be, again, a new niche of expansion for lunar business and the insurance business overall. I forgot to mention that on our first and second mission, we'll also perform our NASA contracts for regolith collection and transfer. We won 2 out of the 4 regolith contract recently awarded by NASA late last year. So we'll collect a few hundred grams of regolith and then transfer that to NASA in what will be maybe the first economic transaction of a resource on the moon. So we're very excited about that. So we'll do the first one with our Lunar Lander in 2022. And the second one, we've actually a rover here from ispace Europe in Luxembourg in 2023. And to quickly wrap up, this is a picture of our Mission Control Center that we opened late last year. And I personally really look forward to seeing live lander telemetry show up on those monitors, along with first pictures from the lunar surface. Our landing site will be Lakis Memorium, the Lake of Dreams, which I think is very fitting for our new adventure. So if you're interested in joining us, seeing the MCC, seeing what we're doing in either Denver, Luxembourg, or Tokyo, reach me out on LinkedIn, send an email, go on our website. We'll be glad to get back to you. Thank you. And I think I saved you some time, Ron.
Thank you very much, Julien. Very good, concise presentation. Lots of good stuff there.
All about being on time.
Which is unusual in the space industry. Thank you everyone for their presentations. Very exciting. We're going to again have a copy of this, or a link to this video after the fact, so that people can take a look and make contact with who they want to talk to and get the information needed. I think at this time we'd like to get all the panelists up, turn on their video, and we're going to ask a couple of questions for the next 10 minutes or so. And then after that, we'll turn it over to Tony for Q&A that comes from the audience. So now I'm going to ask questions, and people just, again, the panelists just jump in and take your turn. and I'd like to hear what you guys think about, what the future for lunar landers. My first question really is more of a technical one. We all know that it's difficult to survive the lunar night, and we know that if you can survive the lunar night, you can do a lot more for both government and commercial clients. Besides that technical hurdle, though, what are some of the other challenging and needed technical improvements that you see your company doing to improve lander performance as you go down the road 3, 4, 5 years? Anyone want to take that first?
I can take a stab at that. So we believe that the technologies that we're developing for the early missions will be directly applicable to later missions. So our ideas are to take technologies that we're developing for our first couple of missions, apply them to our larger landers, and advance those technologies as we land and get better data. For instance, the hazard avoidance systems that we now think we can get plus or minus 50 meters on. After the first couple of landings, we think we can get down to plus or minus 15 meters of landing accuracy. Our engine technologies, we've already we have a 900-pound engine that we're flying for IM-1. We've already used that engine and developed a 3,500-pound engine, which we tested for an HLS test for another company. So we see just taking the technologies that we already have, expanding those technologies and advancing them over the next couple of years.
Great, thank you, Trent. Appreciate it. Anyone else want to jump in on this?
Sure, I can maybe take a different approach on it. Just to say, it's not all just about landers, right? You can provide a lander service with other additional infrastructure. So two things that we're working toward are having a launch vehicle that can support TLI delivery for a lot of the landers in the class that all the providers here are discussing. Right now, if you go on like a Falcon 9, you're using something like half the capacity to TLI. So it's a lot of rocket to buy for that kind of mission. And then also an orbiting asset is another thing that we're seriously considering, just so you can do those far side missions or carry a larger antenna than you might want to carry to the surface for a comm relay. So there's some additional assets that would really enable different kinds of lunar surface missions, but aren't necessarily tied directly to the lander.
Great.
Sorry. I just might add, from our perspective, there's a real need to start thinking about the surface infrastructure itself. So once you have regular low-cost deliveries, what do you do with that? You have potentially power needs, comm needs, as highlighted. What are the actual surface assets to get that done? And obviously it starts with rover mobility in a big way, but then there's additional pieces that are going to be needed. And we think it's important that the community start thinking about the niches. There's plenty of lunar lander companies, as you can see on this panel, but I think now there's an opportunity for other companies and the whole ecosystem to start thinking about infrastructure for longer term missions that survive the night and cycle through and stay on the surface and operate.
Great, thank you, Dan. Anyone else?
I can jump on that.
Good with that. Oh, please go ahead.
Yeah. Yeah, so I liked what Dan just said about, expanding the ecosystem in the second phase, which in my view really brings to light the second half. You mentioned technical challenges, but the real challenge in my view is the business challenge. We can't depend on NASA contracts, agency contracts to, sustain these companies that we have here today. So we need to show that there's actually a sustainable business model, around the moon and the lunar economy. Which is why, as I said, we also, spend a lot of effort developing the data analytics, looking at mission planning, looking at the business feasibility, technical feasibility of space resources to really mature the space resources value chain as we also bring down the cost of transportation. Because that's what's going to sustain all of us here.
And Ron, sorry, I had something to add here too. I know you said besides survive the night technology, that is something we are working on. We have a NASA tipping point for our metal oxidation warming system, kind of similar to hand warmers. So that's one of the things. The other things we're thinking about are, far side communications and how can we best support that for future missions. And and things such as like a sample return architecture of how can we bring something back in the future. So those are kind of the thoughts we are thinking about.
Great. Appreciate everyone's input. Another thing I wanted to talk about, and I think Julien touched upon it in his response, is we have, NASA and other space agencies supporting this segment of the industry with CLIPS and other programs. You guys are supplementing that with commercial payloads and working to get more commercial payloads manifested on your landers. When do you see the tipping point happening when the commercial payloads and companies start actually taking more of a precedence in what you're doing, where they want to go, how much they want to bring to the moon, and so on, as compared to relying on NASA, ESA, and other government agencies for that?
I might take a stab at that one. I think the first key is to have successful missions. There's a big burden that all of us as companies have to not only execute technically and actually stick the landing, if you will, but also to prove that the business model works at the costs and prices that we're talking about. So those are two, I think, big markers that the broader market will want to get precedence on. I also think it's important for us to be thinking about things like future ISRU. It's not going to be something that happens next year or 2 years from now. But I think there's going to have to be important ground truth measurements done of things like the content of lunar water ice. Where is it located? How hard is it to potentially extract? There's big questions of things like, is it harder to get it out of just the top level regolith potentially, or do you have to actually go into a PSR to get something that's economically meaningful? Maybe it's actually easier just to get little tiny bits of it across the surface over a wide area, as opposed to operating in the incredibly cold and difficult to operate regions like a PSR, permanently shadowed region, I should say. So those are kind of like, once you kind of break through that and you show that there is viability potentially in utilizing that water ice, that's an incredibly exciting opportunity that there could be follow-on investment, I think, from outside of space agencies.
And I would say that in order for a commercial customer to, one of the questions you asked was whether or not the commercial customer could pick the landing site, if you will. In order for the commercial customer to pick the landing site, it has to be a pretty large percentage of the overall cost of the mission, right? Someone who wants to pay for 1% of the mission, but then wants to pick the landing site, that's probably not going to be a viable alternative. So I believe that the market will take 4 or 5 years. I agree with Dan that we have to understand what is there, what would drive that market, but it could easily be 4 to 5 years, maybe longer, before the commercial companies or commercial entities start driving some of these missions versus governments driving the missions.
Great, thank you, Trent. Anyone else want to chime in?
To just elaborate a little bit on what Dan said, they got to stick the landing, stick to the cost, and stick to the schedule. I think are the three main things to generate confidence in the commercial industry. That's why we're actually rooting for all of our competitors to be successful on these first missions.
Oh, that's great. Anyone else, or we go on to the last question? Okay, and that way we'll be on time, which is wonderful. So my last question is that NASA and other agencies want to go to the lunar South Pole for obvious reasons, as Dan mentioned, PSRs and water ice and those kind of things. What are some of the other like types of locations do you see people wanting to drive missions towards, other than, let's say, the lunar South Pole? Are there any other areas of interest that you see possibly servicing with your landers?
I think we're hearing a lot of sites. So more South Pole, North Pole, more PSRs, a few mid-latitude. It just seems like the whole gambit here that they're looking at right now. from my perspective.
Yeah, if you ask 4 lunar scientists, you'll get 10 different opinions on where the best place to go is.
Yeah, that's what I was going to say. I think the human missions are focusing on South Pole, North Pole potentially, but definitely the scientists they're all over the map. So they're going to, you ask any one of them, they're going to find some place. I was talking to ASU, and they wanted to land in a pit in the Sea of Tranquility. Probably not very much value to anyone else, but really cool science.
I think it's maybe worth mentioning also the approach the European Space Agency is taking related to volatiles and resources. They're actually not, I think, willing yet to bet on volatiles for the reasons that Dan mentioned earlier. There's a lot of things to demonstrate there. And they recognize there's oxygen pretty much everywhere you go on the moon. I think the regolith is about 40% oxygen on average. So that's their approach. They don't want to select a landing site. They want to do space resources, but focusing on oxygen because it's widely available. And that also opens up a lot of opportunities.
Right. No, there's quite a bit of opportunities. And like some of you said, it's going to take some initial success, sticking the landings, initial characterization, getting the data back, and then that will probably drive the demand to where folks will want to go on the moon using your services and others. Well, I want to thank you guys for the panel discussion. We're back on track time-wise, so I'm going to turn over to Tony for the last 15 minutes of Q&A.
Thank you. Thank you, Ron. Thank you, everyone, for the nice presentation that you've made. Ron, can you just come back online? I would like to take a photograph of every one of us before we go. Hey. Ron, can you come back? I guess Ron just went for coffee. Great. Okay, I just took one of us 6. So I'll take some Q&A from the attendees, and I will just read them out. First of all, I have a question for myself as an ex-regulator and as a regulator myself, in a sense. Now, how do you go about your licensing and your activities on the moon? Are you ride sharing through a license or through a government, basically, going on the moon, or are you waiting for some kind of approval from the country from which you're going to be working with and launching, basically? I know there's the prevalence here is the United States with 4 of you, and 1 is in Europe, basically. But is there any impact to your success of the mission, or are you waiting for something to happen so that your mission is approved for launch and operate on the moon? Who's going to take this? Julien, you're the only European here. Maybe you can start, then we'll go to Will or Stephanie or Dan.
Provide a slightly different answer than you were expecting. So ispace Europe here, we're not involved in the lander side of the business for ispace. So that would be more a question for our Tokyo colleagues. However, as I mentioned earlier, we won one of the contracts for the regolith collection and transfer of ownership to NASA. And the exciting part of this is that we will be the first entity in Luxembourg to really exercise the space resource law that was passed in 2017 by Luxembourg. And Luxembourg is the second country after the US to have such a law authorizing ownership of resources on the moon and other bodies. So we're really happy about this, make a bit of history for Luxembourg and the rest of the world.
Thank you for that, Julien. I find it a little bit amazing, the answer that there is a country that is willing to not respect maybe the international treaties, but let's see what happens when this happens, when it comes. Stephanie or Will, or I don't know, Trent, Dan, do you have
Sure, I can try and go by memory a little bit. So there's a UN space treaty, governing what you can do on different planetary bodies, including the moon. For most of the moon, it was actually revised pretty recently, I think in the last year, for most of the moon, all you have to do is tell the US government where you're going and what you're taking. You just have to declare it. So there's not really a lot of problems there. I think there are some constraints maybe for the polar regions, but that's not where we're landing. But more of the licensing issues are, getting your FCC license taken care of. It can be kind of a long lead item.
Makes sense. Anybody else?
Besides that, you obviously have your communication licenses that you have to get in place, your launch licenses that you have to get in place. Usually your launch company is helping you deal with that. We have one mission that's a ride share and one mission where we have the entire rocket. So the infrastructure changes just a little bit, but it's just like launching anything else into LEO or GEO. With the one exception, that is you do have to tell the government where you're landing on the moon, and you can't land at places that the United States, if you're a United States company, you can't land at places where the United States considers them to be historical sites, like the Apollo 11 site.
Okay, well, thank you for that. The other question I had was on the far side of the moon. When will far side of the moon happen?
I think NASA's saying 2024. Someone can correct me if I'm wrong.
NASA's saying 2024 on their Prism 1B mission. If you ask the Chinese, they'll tell you they're there right now.
Well, they are. I agree. Okay, I'm going to move to the Q&A on the box that below. There's an anonymous attendee who's asking some question on the frequency bands and protocols which your landers use or landers will use for communication with the Earth. Anyone can answer that? So what sort of communication system the landers will use, and what sort of frequencies bands are going to be used?
Yeah, so
I'm happy to speak to data rates, but I'd rather not specify technical info.
I'll answer for Intuitive Machines. We're currently using S-band, and we know others are out there looking at S-band and X-band. We went S-band because we wanted to have a fully commercial, non-deep space network reliant system. And it allowed us to go with a reasonably priced option that gave us a pretty large bandwidth.
Okay. Will, you were saying something?
Sorry, just to add, we're doing X and S on our first mission.
Okay, it's pretty much standard, the X and the S bands, I see. Will, you were saying something?
Oh, no, I just said I'm happy to speak to data rates. We're offering up to 10 megabits per second downlink, which is pretty substantial. Probably guess which band from that. I don't know if anyone wants to volunteer for going optical, but I think that's not too far out. It is a very good technical solution for the moon. It just needs a little bit more of a demonstration, I think, before anyone's going to adopt that.
Okay. I know that Commstar is actually utilizing most likely a mix of frequencies and optical as a relay satellite on L1, Lagrangian point L1. That will help also some of the missions as opposed to have lower power requirements on the surface of the moon. If you radio relay it or optical relay it at a midpoint to the Earth. I'm going to move on to the next question I have here on the screen. Let's see, can you land anywhere on the moon? And another anonymous question, let's say next to another company or country, or is there a restriction where to land?
Well, from ION's perspective, we can land anywhere on the moon. We prefer not to land in places where it's dark and we can't see the Earth, but we physically could land anywhere on the moon. The only exceptions that we have in the United States are the ones I mentioned earlier. We can't land within a certain vicinity of the Apollo landing sites.
Okay, Apollo landing sites or other countries' landing sites will be off, I suppose.
Well, I'm not sure it's off, but I don't think it's probably a good idea.
Well, if it's not a good idea, then it's off, basically. As far as I can understand. Anybody else wants to say anything about this? Otherwise, I'm going to move to the next question.
Yeah, just that I'll add that we take a product line approach with our landers, and so they're capable of landing any latitude. and with an orbiting asset to do relay, the far side is also accessible. So it's similar constraints to probably many of the other providers.
Yeah, for ispace, the first mission is, as I mentioned, like a subnoium, 38 degrees north, so like a mid-latitude. And then we go to the pole for the second one.
Okay, I have Pier Paolo asking a question which was sort of partly answered about the COVID impact on the market in 2020 in terms of monetary and project timing terms, how this will affect the future plans. And then Pier Paolo came back saying he was also thinking more in a global terms. Did you see the overall market slowing down with projects canceled or delayed? I think that was answered by Will, but go ahead, Will, if you want to take that again, or anybody else.
Sure. So for us, there was, initially when we were switching to almost 300 people working remotely, that was, a little bit of a tax on our IT infrastructure to facilitate that. But we've actually seen quite a few rewards from that. And some people are actually putting in quite a few more hours as a result of having just everything set up and ready to go at home. For our supply chain, there have been some delays related to that, but we purchased stuff far enough out that it didn't really have a big impact on us. And for our launch side of things, we're mostly buying raw materials anyway, so there wasn't really a big impact there. We haven't seen a slowdown in customers. We've actually probably seen an increase in the last 3 or 4 months, possibly from pent-up demand.
And Tony, from our side, I started during COVID. I came to Masten in August, so it's been during the pandemic that I started there. Masten was already set up with people working remotely. So some of our team is in Atlanta working more on the business side. We had people in New York, all over the place, but most of the engineers work hands-on on site in Mojave, California. And so with COVID right now, we've been able to, and we're enabling employees to work remotely and take advantage of this moment. And so as we're hiring and bringing more people on board, like me, I'm in Northern Michigan. No one else is in Michigan at Masten, but we're finding out ways to work well together and keep our culture alive as we're spread out across the country or planet in some cases. So we have come up with unique ways to stay engaged, and having only ever met one of my coworkers in person before, I would say we're doing really well. I think that there's a really good culture being built up internally during this remote time.
Thank you, Stephanie. I think, in fact, space has been actually very active in this last 10 months with the COVID pandemic, I have to say. A lot of people work from home, but also a lot of people working from the factories where they have to manufacture, irrespectively. I think that's still continuing, basically. Anyway,
yeah, and that's the biggest challenge that we're facing is the factory floor. If we have a vendor that's out in California or a vendor that is in Spain and someone gets COVID, now everyone that came into contact with them is out for a couple of weeks, and the hardware gets delayed. So that's been our biggest challenge. It's a daily event of what's the COVID impact today on our hardware deliveries.
Okay. Anybody else? Otherwise, I'll go to the next question. Last one.
Well, I'll echo what Trent just said for the negative aspects, and for the positive, I think Stephanie also, surprisingly, COVID kind of brought us together across all our 3 offices. We're in Denver, Luxembourg, and Japan, and now we're just one big team that's working remotely in a way on Earth, as opposed to being 3 different teams. So that was unexpected and kind of cool.
Okay, last question I have here on the Q&A box is from Clive. Is there a connection between Firefly Aerospace and Dragonfly Aerospace in South Africa?
We are familiar with them, but no, we're not flying any Dragonfly hardware on the Blue Ghost lander. That answers the question. Or at least not this time. The trade may come out in their favor. We'll see.
Okay. I only have 2 minutes left. If you see this question on the Q&A panelists from Elizabeth, which are the most challenging areas, projects, products, or services? It's quite a broad question, I have to say, your company at the moment. And where are you guys spending most of the time and efforts?
Sticking the landing is the most challenging part of this. People know how to fly in space. Soft landings on the moon are hard. 2019, 2 countries managed to not stick the landing. It is a very challenging feat for all of us. So I agree with Will. I think we all are rooting for each other because that drives the market forward. We have to prove that this is commercially viable, that we can do this with commercial companies, not governments. And in order to do that, we need to stick the landing.
Yeah, I'll say absolutely agree. It's incredibly important, I think, for all of us to have the right expectations that we're all flying to the moon for the first time in the U.S. since Apollo 17. So, and as Trent noted, there have been some recent failures. So it's incredibly important, I think, all of us to, as a community, to kind of stick together and help realize that there is the potential for miscues and things that might go wrong, but we should maintain course because this is an important endeavor for the entire space community and for the future of what we're doing. So, you know, like let's maintain the course and remember how hard and challenging this is.
Thanks. There's another question from, I'll take it because I think it's an important one. How is the navigation and GPS-like navigation service on the moon? How is it easy or difficult to navigate your missions?
Since we're taking that payload, I guess I can speak to that. It would perform a nice check on our GNC solution, right, to be able to verify that we are, in fact, where we believe we are. It, of course, would only work for near-side missions. And there are also some challenges with that because you need to be steering an antenna toward the Earth during your final descent. So it would be an excellent verification, but it by itself is not a landing solution.
Yeah, so, and with that in mind, that's why we're very heavily invested in terrain relative navigation. We have that as a capability that we're testing on our first mission as a payload. It's our own payload, and then we're going to be relying on it in the Griffin Viper mission. So it's a tech that's incredibly important because there is no real GPS to be relied upon in the lunar environment. And so that tech is something that we offer commercially as well to other lander companies and other folks looking to do precision landing. It's probably the best way to attack that before there is any kind of longer term infrastructure for guidance. Yeah,
and the advantage that the moon provides us is it's pretty stable in what you're looking at, right? The craters haven't moved in a very long time. So as you're looking down, you can identify those craters. You can identify them optically with cameras. You can also identify them with LiDAR. So you could land in the light or land in the dark. Both are possible.
Okay, interesting. Ron, can you come back? We'll take a last photograph if you're still online.
Yep.
Okay, thank you to all the panelists and the participants for being here today. I'm going to take a photograph of the panelists. Another one. Thank you so much, and we'll see you next time. All the best. Thank you, guys.
Thank you.
Tony.
All the best.
Thank you, Tony.
Thank you, everyone.
Bye-bye.